Thank you so much for being here and welcome to the Clean Water Conversation series. My name is Julia Rastelli and I use she, her pronouns. I am an Eco-AmeriCorps member serving with the Clean Water Initiative program at the Vermont Department of Environmental Conservation, and I'll be facilitating today's conversation. Our speaker today is Dr. Lesley-Ann Dupigny-Giroux, Vermont State Climatologist. She'll be discussing the connection between climate change and water quality in Vermont. Our next Clean Water Conversation is on Thursday, July 11th at 12 p.m. Ryan Patch and Nina Gage from the Vermont Agency of Agriculture, Food and Markets will discuss the intersection of improving water quality and climate resilience on farms in Vermont. The link to register will be added to the chat at the end of today's conversation. And today's conversation will begin with a presentation from our speaker, followed by a question and answer period at the very end. You can write your questions in the chat and I will read them aloud during the Q&A, or you can use the raise your hand feature during the Q&A to verbally ask your question. This conversation is being recorded and will be made available on the Clean Water Initiative Program YouTube channel. With that, I'll turn it over to our speaker.
Well, good afternoon, everyone, and thank you, Julie, for the introduction. Thank you again for having me here as part of the conversation series. And what I'd like to do, I'm going to get my slides shared here. I just saw Donna. Hi, Donna.
Hi there. I was trying not to interrupt.
Not a problem. It's always good to see familiar faces. So what I'm going to talk a little bit about today is some of the intersectionality between weather, climate, and climate change, and some of the things that we could be thinking about in water quality connections, and hopefully leave a lot of time for some Q&A at the end of it. So I'm just going to dive straight on in. And I was coming back from the American Association of State Climatologists meeting 2 Saturdays ago and flying up. It was in Fort Collins, Colorado. And so we took a different flight path, which allowed me to see parts of the landscape, which I don't usually get to see. And so really interested to look at the water quality and levels along the Otter Creek here as it sort of flows northward and empties into Lake Champlain and here, and looking at all of the tremendous amount of sediment that is present, not just in the creek itself, not just in the mouth, but also sort of like moving into the lake. And so I'm thinking about that relationship between the very interesting spring that we've been having, the going between a lot of the hot and dry days and weeks, and then moving into precipitation. We seem to be stuck in a really, really active pattern right now, and what that means for moving water, moving sediment, moving phosphorus, and all the other pieces that we are thinking about, not just in the waterways themselves, but into the lake itself. And so thinking about that really, really active pattern, this is a shot back last week, so last Thursday. And if you're looking at this, you're seeing all of these systems move across, not just Vermont here, not just the Northeast. And as these systems move, you're seeing the very, very important influence of our topography. So you're seeing the sort of north-south stagnation of a lot of these events. You're seeing all of these frontal boundaries. And then right here, you see that effect of systems that blow up over the Green Mountains where they're forced to rise tremendously. So that's that pattern that we've been seeing, not just this week, last week, but since that heat dome actually got dissipated. So that was last week. That's this year. That's spring. I can do the same thing and go back to last year, which is, I think, what spurred a lot of the conversation and the theme of the series for this year. So last July, the 9th to the 11th, we had this multi-day event where, again, you're seeing a lot of stagnation of systems, but in this case here, the stagnation was in place. It's not sort of like just moving through. And so this is from the 10th of July, and as you look at it, you're seeing a lot of these very potent storm systems along the central part of the state itself. And you're seeing moisture move into the state. And if you look really, really closely, all of this was taking place against the backdrop of all of the wildfires with all this smoke, there's that smoke coming in. All of this is going on all at the same time. So we're looking at these compound events, we're looking at these complex events, and we're trying to understand as the system evolves and as it changes, how to sort of parse through and how to make sense of trying to set up new strategies for resilience, or how it kind of plays out for us as we understand the systems continuing to move through for us. So that event, that multi-day event, the 9th to 11th of July last year, on the left-hand side here, we're looking at a radar image, sort of composite of the heaviest precipitation, which in this case here, if you're looking at the key on the right-hand side here, the yellows and the oranges show you where that heaviest precipitation was falling. And so again, that bullseye in the central part of the state, as all of these systems kind of move through, producing a lot of that significant and catastrophic flooding that we saw last year. So we cannot talk about water in the state of Vermont without talking about topography. So just to get us situated here, why storm systems, why fronts tend to have that orientation to them, that sort of southwest and northeast orientation. Part of it has to do with the fact that the Greens and the White Mountains are extensions of the Appalachians. And so there's that sort of west to east movement. And when it hits the orographic barrier, that topographic barrier, and is forced to rise, you see that blowing up of events or stagnation of events in here. And so it's not an imaginary barrier, it's a very real barrier on the landscape. And so it sort of plays out not just in the summertime or the springtime, it plays out all year round. And as you look at this lower diagram here, what you're seeing is a few years ago when we had an icing event, there was icing on one side of that barrier, which is what you're seeing here in the greens, but snowfall on the other side. So there's a very, very clear line as to why you see certain types and amounts of precipitation as we step on through. So zooming into the July event, that topographic, that orographic signature very, very clearly imprinted on the landscape here. So the location of your greens and the tectonics in the southern part of the state here, giving you that sort of anchor for where the heaviest precipitation events fell. So heaviest values are going to be those purple colors here. So you're looking at anywhere at over 7 inches along the spine of the greens. And then as you get into the Champlain values, you get into the Connecticut valley, those values literally drop off very, very quickly. So we're looking at this, we're looking at the types of flooding, we're looking at whether it was both riverine flooding as well as flash flooding on the localized level, and thinking about the lakes and creeks and rivers that we know are flowing through this really complex part of the Green Mountains that we see across in here. So looking at some of the crests along the Winooski itself, we've got on the upper left Montpelier, Essex Junction in the middle here, and Waterbury on the right. These are some slides from my colleagues at the National Weather Service, Burlington International Airport. And what they've done is they've sort of pulled out the hydrographs for each of these three gauging stations, and then gone back and looked at the July 23 event in terms of their crest relative to some of the largest floods on record. And so it's interesting to note that as catastrophic as it wasn't the highest values that ever been recorded at each of these three gauging stations. And what this speaks to is the need to really have as long-term records as possible so we can set it into the context that is from a historic perspective. So for a lot of the regions here, so for Montpelier and Essex, we still go back to the 27 flood in here. And then at Waterbury, Irene was the new flood of record that took place in here. So we're comparing it to that. And if you look at some other major rivers and other gauging stations along them, so here's the Otter Creek, and again, tapped off by Irene. Looking at the Loyal at Johnson, so just north of that, back to the 27 flood, because the 27 flood is still the flood of record for most of the northern part of the state itself. So when we look at all of these events and again try to put them into the long-term historical context, again, this is a Weather Service slide, and what they've done here is to pull out some of the more major ones here. So not just springtime events, not just summertime events, but looking at it across the entire year. And that takes us back to the fact that flooding can occur in any season for a number of different reasons, including icing. And so we've got the ice storm of 1998 in here because there was a tremendous amount of flooding that took place in the winter. And we'll see that theme repeated again in a few more slides in here. And looking at some of the other events that were markers for us across the state, 1973 was another one that a lot of last year's floods got compared to, but we're also looking at when we have tropical storm remnants or the storms themselves moving across the state, how that sets up the tremendous amount of precipitation that can then lead to either very unfortunate loss of life, but also a lot of infrastructure damage as we step through. So here are some shots that, again, were put together and compiled by the Weather Service at Burlington, looking at the unfortunate damage and loss that occurred during July of last year, the high water rescues as well. And then comparing that to what we saw during right after Tropical Storm Irene in August of 2011. Very similar stories playing out, very similar amounts of precipitation. And one of the things that probably Nina and Ryan will touch on next week when they come and talk about this, whenever floodwaters touch crops, they have to be destroyed or disposed of because of the potential for contamination. So there are multiple sectors that water quality and water quantity are important too, that have touch points on. And so we're looking at some of these in here, making sure we're doing as complete thinking as possible. So Irene is now the flood of record for the southern part of the state. And part of that is because of the trajectory of the storm itself and how it sort of moved from one basin, the Hudson Champlain Basin here, across to the Connecticut Basin. And as it did that, the heaviest amounts of precipitation were observed in the southern part of the state and very much less in the northern part of the state, which is why we saw a lot of that flooding down in that region there. So this map was compiled by Jonathan Croft at VTrans, and what he did was to look at all of the road closures, all the roads that were affected during Irene, which if you look really closely, you might be able to see the yellows and the greens and the reds. And he superimposed that on a similar map of flood damage from 1927. And as you can see, if I go to the next slide here, so we blow it up for the central part of the state a little bit better, a lot of these are sort of one-to-one. And part of that, of course, is historical and cultural, where the roads have been in. They've been in the same place for the last 300 years or so. And so it helps us to actually get a jump on where the vulnerabilities are, at least from an infrastructure perspective, because we know where those rivers and infrastructure touch points actually come in play. So that brings me to something that I realized a long time ago. It's that juxtaposition, that coming together, that closeness of where our infrastructure is and has been built relative to where our waterways and water bodies are, and why that sets up that particular set of vulnerability from a landscape perspective. So on the upper left in here, you're seeing the town of Waterbury, I-89 running along through here, Route 2, intersection Route 100, and then the Winooski, when it sort of pinched off and sort of isolated Waterbury. You can see it really, really clearly on this physical map that we have in here. So if we look around the state, we can always sort of pinpoint places that have repeated events for similar reasons, including around the Jay Peak region. So just south of Jay Peak in Montgomery, which is where these shots are from. And then along Route 100 is another sort of preferred place for having these preferred sets of damage taking place. So thinking about that and sort of putting it into our changing climate, how does this sort of play out for us? And the diagram that you're seeing here is one that was created by one of my colleagues, Dr. Jason Schaefer, when we were spearheading the writing up of the climate change section of the Vermont Climate Action Plan. And so what he did here is to try and put together the various hazards and the risks that are associated with those hazards across the entire state, across the entire suite of natural hazards. So it includes temperatures, it includes different types of precipitation, it includes different seasons, and it also includes winds, because sometimes we forget that winds are a very, very critical part of our ecosystem, our climate ecosystem in here, and produce tremendous amount of damage because, again, of our topography. So we've got our best guess right now as to whether things are going to increase or decrease, and then the confidence that we have. So we're always a little bit more confident when it comes to precipitation, less confident when it comes to certain types of storms like thunderstorms and winds, because not just the dynamics, but the number of events that we have to actually sort of do an attribution for. So weather, climate, and climate change are all local. And one of the reasons why I put this diagram up here is this goes back to the droughts that we had a couple years back. And we're looking at some of our eastern counties, and it's possible to have part of the county be in drought, which is the sort of browns and oranges color-wise that you're seeing here, versus the other part being actually with average, or what climatologists call normal precipitation, or even excess precipitation. So when we were thinking about some of these processes, we're thinking about some of the mechanisms and tools that we want to apply, we have to make sure we're doing it at the appropriate spatial scale and temporal scale, and can't be a blanket event in here. So that was a sort of precursor to talking a little bit about water, whether it's too much water or too little water, because both are critically important to us here in the state. And so if we look at this, we have two different variables that we can look at from a climate change perspective. The upper one is temperature, which I'll spend less time on because we're more focused on water today. And so that's that lower diagram. And what you're seeing is we are getting fewer and fewer events where you get low amounts of precipitation. So what you're looking at on here is the previous climate, which had more light events, and as the entire climate regime is shifting, we're getting fewer of those, and so that's what this solid line is across in here. And conversely, we're getting more times when there's heavier precipitation. So that solid line here shows that increase in terms of precipitation. So a lot of excess or excessive precipitation leads to flooding, but flooding can occur for a number of different reasons, as we've mentioned before. So you're probably very familiar with this this hydrograph of Lake Champlain, which runs daily. And so this is the entire hydrograph for 2023. And just to get us oriented really, really quickly, the blue lines here show the highest daily value that has ever occurred for all of the records dating back to before 1900s. The green line here shows you the lowest that it's ever been. The purplish line in here shows you the median value, which leaves a red line as the actual year itself. So in 2023, what we saw is that Lake Champlain actually set a number of records, including the July floods themselves, okay? And then as those floodwaters continue to move through the system, we set another set of records in August, moving into September. And then at the end of the year, we set some new records in December itself. And so looking at these and sort of parsing out why, when, and where, critically important. And part of that is because a lot of changes are actually taking place during winter. And so if we only focus on summer, we might be missing part of the story here. So looking at these changes in winter is critically important as well. And so this is another diagram that Jay and I put together for the Rural Resilience and Adaptation Subcommittee of the Vermont Climate Council. And what we're looking at, again, so these records go all the way back to the late 1800s. So we're really getting the long-term context here and looking at the ways in which temperatures are changing, as well as precipitations are changing during the winter season in particular. So on the upper right-hand side here, what Jay pulled with the warmest winters on record being all the way back through to the 1800s. In the case of Burlington, these records are the ones that have been at the airport since the airport was started. And so we're looking at this current winter that we just came out of and looking at the other ones in the top 10. And it's important to note that a lot of the records are recent, but then there are some others that also date back to the earlier parts of the record itself. And these are important, again, for setting the context for the changes that we're seeing. So why are we seeing a lot of changes in winter? And part of it is because the difference between our polar regions and where we live in the mid latitudes is changing. And so what you're seeing is, if you can think back to a lot of times, and you may have read in the newspapers where these cold outbreaks making their way all the way down as far as Texas and other places that are currently not prepared for having cold outbreaks, and how quickly that changes. So you've got 23rd December here, you've got the 30th of December here, and that very, very stark contrast between going from cold events to really warm heat wave type events, and what that means, not just for the landscape, but for us as humans themselves. So if I click on this, what you'll see is this animation of how quickly this can occur. And as we're looking at this and learning more about it, it's not just the atmosphere where we live, but a lot of this is also part of the atmosphere above where we live. And knowing that we need to continue to make those connections across the board from an atmospheric perspective so we can understand why we see the events temperature-wise and rainfall and precipitation-wise that we see on the ground itself. So what does the hydrograph look like today? So this is as of yesterday. And as we're looking at this in here, we've noticed that we're trending back down below the median line. And even the rainfall events that we've been getting, those continuous very high active pattern that we've been seeing for the last 10 days or so is producing some change, but not tremendous in terms of trying to get us out of the dry conditions that we are right now. So this is a great way of sort of looking at how all that water moving through the entire system makes its way into the lake itself as an integrator of our response. So we can also look at the temperatures, because temperatures are also going to be critically important for us, particularly if our warm conditions. Perfect. So this is where I popped off, and I was talking about the water temperatures, and looking at the fact that we just set another set of records recently here, and the importance of that for not just the habitat in your streams, but also from a lake quality perspective. We're looking at harmful algal blooms, and we'll talk about cyanobacteria in a sec here. So you're probably all familiar with the tracker in here. And as we're looking at this, looking at the fact that we've got some high alerts present. So one is for Shelburne Pond and one is for Triangle Beach on the lake itself. And then there are a couple other hotspots where these low alerts in here. And then there's another one up just across the border with Quebec that we're looking to see and monitor as these occur. So part of why we look at temperatures and look at the broader influence and underlying processes of what's taking place from a temperature perspective is the need to sort of factor in and understand droughts and flooding in the state of Vermont. So we're looking at a diagram here that comes from NIDIS, and it takes us back to 1895 all the way to present. So this is literally 2024 here. And the way it's set up is that the brown values show you when we've been in drought, and drought is determined by these various levels. So this is starting to get dry, the yellows, and then the D4s are the most severe exceptional droughts, which are the droughts that you've been seeing in the West for the last few years or so. So as you look at this, the upper parts of this diagram show you drought conditions, the lower parts show you wet or pluvial conditions. And so what you notice really clearly is in the early 70s, the regime shifted from being a primarily drought-prone type of system across the state to being wetter. So if I was giving this conversation in 1950, we'd be talking more about droughts than we would be talking about excessive precipitation. So that's important to keep in mind. The other thing that's important to keep in mind is that we have had severe droughts recently in the 2000s and 2020s. And so we need to still understand and think about and monitor for these flips between drought conditions and excessive conditions. And as you look back through time, um, so we got 1909, 1927, 1966, and 2011. As you look back through time, each one of these tells an important story. So early in the 20th century, we tended to be drought prone. The 1960s was a drought decade. 1927 was important because it shows us one of the characteristics of our state, which is to go from a drought to a flood on the order of a couple of days. And that's exactly what we saw last July. 2011 shows us the influence of having different types of excessive moisture, different types of flooding along the lake at different times of the year. So our May floods in here, but also Irene across in this region in here. So flooding, yes, is our number one event in terms of natural hazards and disasters. Like I said before, it occurs all year round for different reasons. But we also sort of need to keep in mind some of the other hazards that are critically important to the state, including our wind events, including different types of winter storms, including the temperature extremes in both directions. And we've seen that. Last week we were in a heat dome. This week, everybody's got their jackets on because it's gone a little bit on the chilly side. So that going back and forth between temperature extremes is something that we need to look at a little bit more at. So the point of this particular conversation is to talk a little bit about how do we build resilience. And as we're thinking about that, it's important to note that some of these aspects of moisture are still a little bit uncertain. And so as we're planning for this, we need to sort of factor in that uncertainty as we get more and more data points, because they help us to understand if the framework or the bounding boxes around which these changes are actually taking place. So this shot that you're seeing here is from the 4th National Climate Assessment that I was the lead author on. Things have not changed from a physical perspective in the 5th National Climate Assessment. And so that's why I continue to show this particular slide here. So we're thinking about what are the aspects of our land to be at the core, front and center. A lot of it has to do with the mixing in of our working in natural lands. And again, we'll probably hear a little bit more about that next week when Ryan and Nina come to give their presentation, working through some of the nature-based solutions that are part of the Nature Conservancy and a lot of the work that they do. And then how do we make sure that all of our projects that we're designing actually either slow down our moving water or filter it through so that less sediment moves through, less phosphorus, less total amount of volume in our ponds, lakes, and rivers actually kind of move through. So these are some slides from Mike Klein, and so speaking to the need to have our rivers be really connected with our floodplains, the ways in which we're trying to minimize the amount of both downstream flooding as well as erosion, because those are the two big pieces that we're particularly concerned about. And again, a lot of the things that went into Act 138, again, these are some slides from Mike in that connectivity of our river corridors, which again is a lot of the focus for all of the folks on this call here. So some of the additional strategies, and I'm kind of moving into ideas that I'm throwing out here. Some of the additional strategies are included in the first ever Vermont Climate Action Plan, which was adopted in December of 2021. And we can go back and see if there's anything in there that might be an option for a crosswalk between a lot of the activities that are part of CWIP. And as part of that, action plan, what I tried to do was to put everything into perspective from all the conversations that I'd been hearing, both in the council, but also from the various subcommittees. And so in the middle here is where we see the various elements of things to keep in mind in terms of our changing climate. So not just precipitation, but our heat waves, changes in degree days, whether heating degree days or cooling degree days, air quality, change in the growing season. When do you warn for excessive heat? And then what are some of the pieces that are wrappers around this? So making sure that we do everything with the equity-centered framework, making sure that all of these gaps that we're trying to identify, we know what we're trying to work through, and then keep an eye out for the things that we still don't know a little bit about. And then how does all this play out in terms of our governance, in terms of the existing infrastructure, broadly speaking, on the landscape, doing this from a biodiversity perspective, and then looking at all of the various pieces of our land use, land cover. So all of those were sort of influenced by a process called the United States Climate Resilience Toolkit. And I actually used that in one of my classes in working with the town of Underhill because they wanted to bring a lot of climate change implications into their local hazard mitigation plan. And so this is some messy brainstorming that we sort of work through and came up with recommendations for water moving through Underhill, for populations in Underhill, for vegetation on the hill, because it's one of the largest producing sugar maple regions in the state itself. So what are all of these pieces that are important? And this was the framework that we used for that. So that framework is a national framework. And if you would like to know more, here's the link at the bottom. But here's what it looks like when you play through it, because it's got very clear steps in terms of what's at risk. What are the hazards that you're looking at? What are types of actions? And it sort of is an iterative process in working through to actually come up with something that is relevant to a local region. And so this was done in the city of Oahu in Hawaii. And so when they worked through it, these are some of the things that they were able to create using this particular resilience framework. So they did it for things like sea level rise, things like precipitation, excessive precipitation, rain bomb, hurricanes. And I bet if they did it this year, they would probably include wildfires as well. So the Climate Resilience Toolkit has a number of these tools that are part of it. And so here is one that's called the Climate Explorer. And what that allows you to do is to put in a zip code or to put in a county, and it will give you any one of these variables of interest. So whether it's excessive precipitation, whether it's heating and cooling degree days, both from an observed perspective, which is what this gray part of it is, but also more importantly, projecting it out into the future. So Climate Explorer, put in your zip code, you'll be able to see some of these things in here. A couple other tools I wanted to just sort of end with. This is what we call in NOAA Atlas 14. And as you're looking at this, what you're seeing is the GIS-based version of it. So this is what the color-coded pieces are with all the interpolations. The yellow lines are what we were using from TP40 back in the 40s and 50s. And so this tremendous amount of additional information that is coming online that will allow us to better prepare for, because the estimates are now going to be better and the spatial resolution is going to be better. So this is Atlas 14. Atlas 15, it's on its way. So I just wanted to kind of flag that, because as we're looking at all of these various precipitation events by return interval, we're able to have some of these tools at our resources here. So a lot of the information about what climate change looks like in the state of Vermont, each state has one of these state climate summaries that's mandated by the Office of Science, Technology, and Program at the White House. And so if you'd like to delve a little bit deeper, you can take a look at some of these resources in here for our state. And then the last plug that I want to make is we don't have enough measurements across the state in terms of knowing where the heaviest precipitation is falling. And so the COCO-RAS program allows us to actually do that. And so there's Jay Schaefer, he's the state coordinator. Seth Kutikoff is the co-coordinator, and I just became a co-coordinator last year. And so every chance that I have, I try and plug folks coming on board to become COCO-RAS observers. So this is as of yesterday. Seth just sent this out this morning. And what we're looking at are all the places where there was a lot of heavy precipitation. You see the event, the influence of that front pattern that we saw in here. So very, very heavy values across here. And there are some counties where we'd love to have a few more observers. So I usually plug this if I'm able to. And Henry Regis is the national coordinator. He visited us last year. So with that, thank you for being here. Thank you for your patience in little technical challenges here, and happy to take some questions.
Yeah, thank you so much. I'm gonna paste some links in the chat. And then if anyone has any questions, I'll read them from the chat, or you can raise your hand. One question that's already in the chat is, would love to know a little more about what the duties of a COCO-RAS observer are.
Hey, Sophie. So what a COCO-RAS observer does is there's a rain gauge that you buy. It's like $25. And what you do is at set times of the day, you have it installed in a place in your backyard. That allows you to actually get a good representation of the rain that's falling. So in other words, you wouldn't have it like literally stuck next to your like your backsiding or like under a tree, because the point is to get as representative an amount that's falling into the gauge itself. So you record that and then you upload it to the COCO-RAS site. And that then goes into the national program, and the National Weather Service looks at those really, really closely because they use them for forecasting. And then if you've been doing it long enough, it becomes part of the National Archive, which is tremendous for us because precipitation is so spatially variable that the more readings we have, the better we're able to actually see how things are changing across the landscape. I would say, Meg, great question. So can folks with existing rain gauge systems use them for COCO-RAS? I will put Jay and Seth's email address, if I can find it quickly, into the chat and reach out to them and ask them if that's okay, because the more the merrier. And Stephen wants to know the URLs of the documents and websites. Absolutely. And if we're having longer periods of stuck weather or weather not moving, does that mean topography is having less effect? So is it Gianna? It's actually the opposite. It means it's having more of the same effect, because if the topography lines up in such a way and your storm systems actually are the same orientation as them, then it literally causes them to get even more stuck. So topography is critical. And if we were in a state like Oklahoma, which has less topography, you probably wouldn't see as much stickiness, right? So the topography is critically important. And also what's going on in the atmosphere just downstream of us. So it's both of those coming together while we're seeing some of this pattern taking place. So we can't have one without the other. So if we just put in there, she found the link to that. Awesome. Thank you.
Marley?
Hi, Lesley-Ann. It's great to see you. Thank you for such a great presentation. I'm going to ask you a question that is deeply unfair, I know, but I think you can probably handle it. Ironically, this morning was one of the meetings of the Ag and Eco subcommittee of the Climate Council. And we are charged with prioritizing the actions in the Climate Action Plan in a mere 5 or 6 meetings. My question for you is, if you were, queen of the world, how do we focus our prioritization, especially in the Agricultural and Ecosystem Committee and with our charge? Do we prioritize soil health? Do we prioritize education? Do we prioritize conservation practices? Any thoughts that you have on that? Understanding that that in itself could be a full hour presentation.
It could, and you and I have been having these conversations for a while, and so I know where some of this is coming from, and I think it's part of the reason why it's so challenging is because they're all important, right? And you know that my favorite word is systems and systems thinking, because if you only do one part of the system, you're going to miss the other part, and that's going to be it's going to come back and bite you, right? And so I think without having seen all of the priorities, but listening to the ones that you just mentioned and knowing the ones that we've been talking with on the state technical committee, they're all important because they're all interconnected. And so I'm going to turn your question on its head and say, instead of starting with in some cases like 100 priorities, right? Or more.
I wish it was only 100. All right.
Yeah, I know, and that's part of the challenge, is the being overwhelmed part. I'm going to turn it on the head and say, can we find the crosscuts that will be, what we'd call co-benefits, or that would serve more than one purpose? So something like soil health is critically important from an actual soil health perspective, but it also sets up the importance for maintaining the vegetation above it, which also sets up the importance for vegetation acting as filters on the landscape. And so if we can find that one thing that does all of that, then all of those sub priorities would fit in. So in other words, I'm talking about meta priorities. And if there's a way of finding those meta priorities, then we will not be negating all of the sub priorities, but they would help flesh out the meta. Because I'm always big on these cross-cutting things and having one thing serve multiple purposes. And I think in the case of ag and ecosystems, we're almost there. We just have to go up one level. So happy to have an offline conversation on what that going up one level might look like, so that the work's been done, right? The fleshing out's been done. Let's take it up to this. So that you say, we're going to do, and part of that is soil health, part of that is veg, part of that is natural working landscapes. And so nobody's cut out of the pie because we're trying to do this instead. Does that make sense?
That's great. Yeah, no, it makes great sense. The challenge, of course, though, is if you go up to the meta level, then you have a large number underneath it that you're still hoping to address, and then you're sub-prioritizing as well. Right. But I very much see that point, and yes, I'm probably going to follow up with you. Love to talk to you more about it. Thank you.
No problem. Great to see you, Marley. Thank you. Oh, so there are more questions here. Thanks, Sophie. And would it be helpful, Julia, if I just PDF'd and sent that to you, and then that way everybody could actually have the links, and I don't have to cut and paste several of them, and then I miss some. Would that be helpful?
Sure.
Okay.
Yeah, that'd be great. I'm going to send a follow-up email to everyone who attended, probably within the next day or so, and I can include that PDF there.
Awesome. Stephen, you'd have all of the various links in there. Yeah.
Thank you. We can give a few more moments for anyone to ask any remaining questions. Otherwise, we'll just finish this off.
Well, thanks again for the invitation to come and chat, spend some time here. And I'm going to put my email in here already. So if anybody has any questions or follow-up and resources, questions, anything else, I'm happy to chat. Thanks for all the compliments in the chat.
Thank you again for being here and for everyone who came to listen to today's presentation. Like I said, I'll send a follow-up email shortly with all of the links that were provided, as well as a feedback survey. So hope everyone has a great day and hope to see you at our next conversation in July as well.
Thank you so much. Take
And
care.
see you, girls.